Good morning, everyone. Our topic for today is cellular respiration. Cellular respiration is a set of metabolic process that take place in a convert biochemical process or energy from nutrients into adenosine triphosphate. Adenosine triphosphate. Or we call ATP. And then release waste products. The reaction involved in respiration are metabolic process. As we call high energy. High energy bonds are replaced by stronger bonds in the products. Reaction is the one of K ways and our cell releases chemical energy to fuel cellular activity. Cellular respiration is considered as exothermic redox reaction which release heat. And the overall reaction occurs in a series of chemical steps, most of which are redox reduces themselves, although technically cellular respiration is a combination reaction. It clearly does not resemble one when it occurs in a living cells because of the slow release of energy from the series of reaction. That's all for our listeners.
To the cycle itself, let me introduce to you first the ATP. So adenosine triphosphate is a short-term energy currency that is composed mainly of the 10 carbon atoms, 6 hydrogen atoms, 16 hydrogen atoms, 5 nitrogen atoms, 13 oxygen atoms, and 3 phosphorus atoms. And take note that there are 3 phosphate groups attached to that particular molecule. And that phosphate groups form covalent bonds and that covalent bonds carry energy. And that energy carrying part is the so-called triphosphate. And to take advantage of the energy, or the high energy bonds in the ATP, there are many cells that consist of the so-called ATPase, which is really or absolutely an ATP splitter. So meaning that ATPase cuts off the last phosphate group of the ATP molecule, turning that 3 molecule into 2 molecule. So from ATP, which means triphosphate, meaning 3 phosphate groups, because of with the use of the ATPase, it can be break down into 2 and can be turned out into ATP or the adenosine diphosphate, meaning meaning 2.
Go.
Now, from ATP, how does it turn out to be ATP again? So I will explain further. So when a carbohydrate or foods are we going to intake, does foods contain energy, right? So so that energy is broken down to the process of metabolism. Energy is released, and in many cases, the energy is used to reattach the phosphate to reattach the phosphate molecule to ADP, meaning ADP is being added a phosphate molecule again from the food that is broken down, turning it to be ATP again. So then the cycle of food making and bond making begins, and cycle is the process. And alternatively releasing energy and storing energy as needed, and energy is produced as needed.
So today, my topic today is ATP structure. So what is ATP? ATP, also known as adenosine triphosphate. It is formed from adenosine triphosphate, or what is called ADP, and orthophosphate. So when few molecules are oxidized in chemotrophs, or when light is trapped by phototrophs, This nucleotide is tremendously important since it is the most commonly used energy currency. So I'm going to explain to you about the ATP structure. So this is the ATP structure. So proteins composed of amino acid. And the second one is polysaccharide. Polysaccharide is composed of monosaccharides. And the last one is fats. Fats composed of fatty acids. So these three of them is the requirements to convert to produce acetyl CoA. So through the acetyl CoA, it will go down to citric acid cycle. And so that's all.
Down food in the cell, ATP consists of adenine, sugar, glucose, and 3 phosphates. And ATP energy is when one of the phosphates bonds are broken, making them become ATPs. By eating and other things, ATPs are the things we run on, like batteries, and when those batteries are used up, they become dead batteries, or ATPs, until they are recharged by water. The importance of ATP. ATP are things our body runs in our body's energy. When we use up that energy, it turns into ATP. Fermentation is an extremely common way of gaining energy from food in the absence of sufficient oxygen. Many microorganisms use fermentation, like yeast, producing ethanol, or animals, fungal or bacterial cells, producing lactic acid. Lactic acid fermentation is one of ours when animals such as humans, mouse exert their muscles or other function behind the oxygen can supply. The cells then use glycolysis to transform the NADH molecule into the NADH, permitting the production of small amount of ATP. This process is very efficient relative to normal cellular respiration. Anaerobic metabolism exists mostly in bacteria, including the bacteria in many animals. These organisms use electron acceptor than oxygen to complete their metabolic cycle. Use carbon dioxide in this way, producing methane or acetic acid, depending on the organism. What is the difference between fermentation and anaerobic respiration? Fermentation exists glycolysis, the first stage of metabolism, to produce usable energy, while anaerobic respiration uses molecules other than oxygen to complete the metabolic cycle. Both methods used to produce ATP, the energy currents of the cell in the absence of oxygen. Anaerobic respiration produces more energy than fermentation, but is used by fewer organisms in very specific situations.
So, fermentation. Fermentation, the chemical breakdown of substance by bacteria, yeast, or after or other microorganism, typically involving effervescence and giving off of heat. The process of fermentation involved in the making of beer, wine, and liquor, in which sugars are converted to ethyl alcohol. So now, the main purpose of fermentation is to release energy into a form of the cell, can use or to convert sugars into ATP. And now the different methods of NADH conversion mentioned above, as well as the amount of ATP produced, are what sets apart fermentation from respiration. As an example, during exercises, people get out of breath because they cannot get enough oxygen to their muscle cells. In the absence of sufficient oxygen, the muscle cells will use fermentation to generate ATP, resulting in the waste product lactic acid. Now, the purpose of the fermentation is to allow the muscle cells to generate ATP and continue to function even when oxygen is absent.
So now, we will talk about alcohol fermentation. So what is an alcohol fermentation? Alcohol fermentation, also known as ethanol fermentation, it is the anaerobic pathway carried out by yeast in which simple sugars are converted to ethanol and carbon dioxide. Yeast typically function under anaerobic conditions or in the presence of oxygen, but are also capable of functioning under the anaerobic condition or in the absence of oxygen. When no oxygen is available, alcohol fermentations occur in the cytosol or yeast cells. Let's explore the process of alcohol fermentation, then see what it means for yeast and for humans. Let's talk about the process of alcohol fermentation. In the process of breaking glucose down to form pyruvate, several molecules known as electron acceptors are involved. Electron acceptors are molecules whose job is to give and take the electrons released, called NAD+, is reduced to form NADH, gathering up electrons to release by breaking one glucose down to two pyruvate molecules. This exchange of electrons that occurs while glucose is being broken down is essentially what helps build ATP. The conversion of glucose to pyruvate creates a total net of 2 ATP. While this isn't as much as ATP as aerobic respiration can produce, it is enough to keep the yeast alive until the oxygen is available. This part may look familiar because it is essentially called glycolysis, or the first stage of aerobic respiration. If oxygen were present, then the pyruvate molecules would enter a mitochondria to undergo the remainder of aerobic respiration. However, in alcohol fermentation, the pyruvate instead stays in cytosol, the GUE interior space of the cell. It is where the second part of the reaction, the conversion of pyruvate to ethanol, will take place.
Fermentation. What is produced during alcoholic fermentation? Ethanol fermentation, also called alcoholic fermentation, is a biological process which converts sugar such as glucose, fructose, and sucrose into cellular energy, producing ethanol and carbon dioxide as a side effect. How does alcoholic fermentation work? Ethanol fermentation causes bread dough to rise. Yes, the organized consume sugars in the dough and product produce ethanol and carbon dioxide as waste product. What are the alcoholic fermentation? Both alcoholic fermentation and lactic acid fermentation pathways change pyruvate in order to continue producing ATP by glycolysis. Alcoholic fermentation is a type of anaerobic respiration that include glycolysis, followed by the conversion of pyruvic acid to ethanol and carbon dioxide and the regeneration of NAD plus from NADH. What is the waste product of alcoholic fermentation? This second part of called is fermentation. The main purpose of alcohol fermentation is to produce ATP, the energy currency of cell, under anaerobic condition. So, from the yeast perspective, the carbon dioxide and ethanol are waste products.
So, good morning, ma'am. So, we have to tackle about the lactic acid. It is well known that it's formed from glycogen by muscle cells when the oxygen is supplied inadequate to support energy production. There are many misconceptions about lactic acid and lactate in the body. Lactate was long considered one of the causes of both fatigue during exercise and the stiffness felt after. So, how lactic acid is produced in the body? So, formation of lactic acid in the muscle, simple explanation. Formation of lactic acid in muscle tissues occurs when the muscle tissues release energy for muscle contraction via anaerobic respiration. That is when no oxygen is involved in the release of energy to the muscle cells. So that is lactic acid. Thank you.
Anaerobic respiration is a respiration without oxygen. The process uses an respiratory electron transport chain but does not use oxygen as the electron acceptance. Anaerobic respiration occurs mostly in prokaryotes. The amount of energy released is lower, between 36 and 2 ATP molecules. The stages are glycolysis, Krebs cycle, and electron transport chain. Glycolysis is the enzymatic breakdown of a carbohydrate by way of phosphate derivatives with the production of pyruvate or lactic acid. An energy stored in high energy phosphate bonds of ATP. And second is the Krebs cycle. Krebs cycle is the production of ATP. And last is the electron transfer chain. Electron transfer chain is the sequential transfer of electrons, especially by cytochromes, from an oxidizable substrate to molecular oxygen by a series of oxidation reduction reactions. The products are carbon dioxide, reduced bases, and ATP. Cytoplasm and mitochondria are the site of reactions, and the reactants are glucose and electron acceptor.